Hello and welcome to our lesson on the properties of quadratic functions. This is going to be from section 3.3 in our Precalculus text. Let's get started. You're going to notice that I have this set up in a grid because there's two formats for a quadratic function. The first function I have written here is called standard form. The standard form of a quadratic function is f of x equals ax squared plus bx plus c. The other form I have written on this side is vertex form. The vertex form of a quadratic function is f of x equals a times the quantity x minus h squared plus k. Probably the first and most important property that you need to be aware of referring to a quadratic function is that every quadratic graph will be a parabola. Now that parabola may open up or down. That's going to depend on the value of a. Notice that every parabola, whether it opens up or down, will have a point called the vertex, which is either the highest or lowest point on the graph. It could also be referred to as the point of symmetry. The vertex will be located right in the center of the parabola. So depending on which form you're in, whether you're in standard form or vertex form, you're going to have different formulas in order to find the vertex. For standard form, we have this formula. Notice it is written as an ordered pair where negative b over 2a would be the x coordinate of the vertex. And then also notice that the function evaluated at the x coordinate of the vertex will give you the y coordinate of the vertex. So this formula of the vertex for standard form is super important. Notice if you're in vertex form, whatever your values for h and k, those are going to be your x and y coordinates of the vertex. So if you're in vertex form, there's really no work to do to get the vertex. You have to just copy and paste the values for h and k. Next, for the axis of symmetry, again, notice if you're in standard form, the value that x equals is the same as the x coordinate of the vertex. And I can't stress enough how important it is that you include the x equal in the axis of symmetry. Because in the parabola, the axis of symmetry is the vertical line that cuts the parabola in half. And since the axis of symmetry is a line, it has to be represented as an equation. Either x equal minus b over 2a if you're in standard form, or x equal h if you're in vertex form. So just to summarize, the three key properties that you need to be aware of regarding a quadratic function is that every quadratic will make a parabola, every quadratic will have a vertex and an axis of symmetry. And you need to be able to find the vertex and axis of symmetry. And one other characteristic that I need to re-emphasize and make sure you understand is that if a is greater than 0, that means if your coefficient of x squared in standard form is positive, or the value of a over here in vertex form, if that value is positive, then your parabola will open up. It's going to make a U shape opening up. If a is less than 0, in other words, if a is negative, then your parabola will open down, like so. Now the next thing that's important to point out is sometimes if you're given a function in standard form, they may want you to convert to vertex form. And there's two techniques that you can use to do that. One technique is completing the square. In my opinion, that's the more difficult technique. The way I prefer to convert from standard form into vertex form is to use the vertex formula the negative b over 2a, notice that is the x-coordinate of the vertex, which will produce the value of h. And then if you simply plug that value into the function, you're going to get the y-coordinate of vertex, which is k. Now the a in these functions is the same. So whatever a is in standard form, it's going to be the same value in vertex form. And then once you know h and k, you have all of the pieces necessary to write the function in vertex form. So again, using the vertex formula to find h and k and then writing the vertex form, in my opinion, is the easiest way to get there. Now, for our first example, to illustrate the properties of a quadratic function in action, we're given f of x equals 2 times the quantity x minus 6 squared plus 3. And we're going to run through everything you need to know about this particular form of the quadratic. So what I want you to notice first is that this is in vertex form. F of x equals a, x minus h squared plus k. And the first thing we want to do is go through and identify the values of a, h, and k. So here we have a is 2. Notice for h, if I circle like this, this actually says negative h is negative 6. And then if I change the sign on both sides, you actually get h is 6. So the way that I cover this in class is I say whatever you see for h, it's actually going to be the opposite. So if you see minus 6, you're going to get plus 6 for h. Got that? H is opposite, k is not. So in this case, we see k is 3, positive k is 3, and that tells me a, h, and k. Now the first thing I want to find is the vertex. The vertex will be h comma k, which is 6 comma 3, and that's it for the vertex. The axis of symmetry is always x equal the x-coordinate of the vertex. And remember, the axis of symmetry has to be an equation. So you have to have the x equal part. Now, before we sketch the graph, the first thing we need to identify is whether this parabola is going to open up or down. And we can see that a is greater than 0. That means that this parabola will open up. So to sketch the graph, we're going to go to the vertex. We lay out our vertex at 6 comma 3. And then here's a cool feature. The a for the first 2 points on either side of the vertex can be represented as rise over run. Let me show you what I'm talking about. So from the vertex, if I rise 2 and run 1, on either side, that's going to get me the 2 points on either side of the vertex. And then I simply need to connect the dots, making a U shape, and we have our parabola graphed. Now, if you want to verify that at 5 and 7, we are up at a height of 5, you could plug those into the function and work it out. In other words, if you need more detail, you could create a table of values knowing that the vertex is 6 comma 3, and then if I go on either side of the vertex, 5 is 1 below, 7 is 1 above, then I can substitute those values into the function, and I should get 5 if what I said about the value of a is correct. And you can verify that if you want, and you can pick more x's if you need more detail. All right, so we've covered an example of a quadratic function given in vertex form. Now let's look at a quadratic function given in standard form. Here we have f of x equals 2x squared plus 5x plus 3. And the first thing I would like to determine is whether this parabola will open up or down. Probably the easiest thing you can answer first. Here we can see that a is 2, which means a is greater than 0, which means that this parabola will open up. And the next thing I would like to find is the vertex. The vertex is minus b over 2a, which would be minus 5 over 2 times 2, and then f of whatever we get from that calculation. So that's going to be negative 5/4. That doesn't make me happy. That's an improper fraction. I would have preferred a whole number or an integer, but if I get a fraction, I can't help it. I got to work with it. And now if we evaluate the function at negative 5/4, we will have the y-coordinate of the vertex. And what a great time to use the calculator. Here we're going to be plugging in negative 5/4 into our function. That's going to give us 2 times negative 5/4 quantity squared plus 5 times negative 5/4 plus 3. And it says the y-coordinate of the vertex is negative 1/8. Now that we have our vertex, the next easiest thing to find would be the axis of symmetry. And that is always x equal the x-coordinate of the vertex. So there's our axis of symmetry. If they ask you to write the function in vertex form, that probably would be the next easiest thing to do. Remember, the vertex form is f of x equals a, which is going to be 2, the same value, times x minus h. Remember, in the vertex, that is h comma k, and minus a negative will make that a plus 5/4 squared plus k, which in this case is minus 1/8, and that would give us the vertex form of this quadratic function. Now the instructions in this particular question also want me to find the x and y intercepts. The easiest of those two to find is the y-intercepts. Okay, I'm about to give you a shortcut here. The y-intercept, remember, always has an x-coordinate of 0, which means that you would evaluate the function at 0, which is always going to give you the value of c. So just so you know here, as a formula, the y-intercept for a quadratic function is always 0 comma c, and in this case c is 3. Now for the x-intercepts, we're actually going to have to let y be 0, so f of x is y, so we're going to set this quadratic equal to 0 and solve. And the easiest way to solve a quadratic is factoring. So we're going to take a little side trip here and cover the 3R method for factoring a trinomial with a lead coefficient. In case you've never seen this before, you're in for a treat. Again, this is the 3R method for factoring a trinomial with a lead coefficient. The first R says to remove, which means we're going to remove the lead coefficient and multiply by the constant. That'll give us x squared plus 5x plus 6. Removing the lead coefficient turns this into a standard trinomial, which is much easier to factor. So now to factor this standard trinomial, we're going to read the signs. They're both going to be plus. X and x to make x squared, and the numbers that multiply to make 6 and add to make 5, 3, and 2. Once you get your standard trinomial factored, the next step is replace. Whatever we removed, we need to replace it in front of each x. So we're going to put the 2 back in front of each x, And then we can do the third R, which is reduce. So in the first set of parentheses, can I reduce 2 and 3? And the answer is no, they don't have any common factors. In the second set of parentheses, can I reduce 2 and 2? Yes, they have a common factor of 2, so I can reduce by 2, giving me x plus 1. And then this will be the factored form of our original trinomial. So back to our original equation, we're trying to find the x-intercepts. Now that we have our quadratic factored, we can set each factor equal to 0 and solve. And we can see we're going to get two x-intercepts. X equal -1. And for the other x-intercepts, 2x equal -3. Divide both sides by 2. X is -3/2. At this point, we have enough information to get a pretty accurate graph of this quadratic function. Okay, so to the coordinate system, the first thing we're going to plot is the vertex. We're going to have to estimate -5/4 is a little bit less than -1, and -1/8 is barely below the x-axis. So that's going to give us a point. If I could zoom in on that, that's going to be somewhere about here. So there's our vertex, -5/4, -1/8. The next piece of the puzzle that we're going to graph is the y-intercept, 0 and 3. And I'm going to try to keep my scale the same so that it looks nice and neat. Next are my x-intercepts at -1 and at -3/2, which would be -1.5. And again, if I zoom in here at -1.5, I'm going to have an x-intercept. Now, I'm hoping that you can see as I zoom in that we do have the nice parabolic shape happening here. So through the vertex, we're coming up like this, and then up like so. And that's going to do it for that particular example. Finding all of the information they ask for and sketching the graph of the function. And for our last example in this particular lesson, we're going to look at what happens if they give you the graph of a quadratic function and they ask you to find the function. So here what we're given is the vertex. Remember, the vertex is the ordered pair h, k in vertex form. And this other point they've given us, that's just a generic x, y on the graph. So since they gave me the vertex, what I'm going to do is I'm going to start with vertex form. In order for you to have the quadratic function, you do need values for a, h, and k. If you know all three of those variables, then you have your quadratic function. At this point, we only know h and k. We're going to have to find a. And here's how we're going to do it. F of x is y, and I do have a y given. The y for this ordered pair is -2. Remember, a is what we're looking for, so we're going to have to find a. And then I need an x, which I do have an x given in this ordered pair, -4. Minus h. H we know is -2. Remember, minus a negative is going to make that a +2. Quantity squared plus k, which we know k is 6. And notice I was able to replace all of the variables except a, so we can solve for a. Okay, so following the PEMDAS, the order of operations, we're going to do what's in the parentheses first. And then exponents. -2 squared is 4. Now, since that is indicated multiplication, knowing that multiplication is commutative, I can write it as 4a. Order doesn't matter. And then I'm going to move the 6 over to isolate the term with an a. giving me negative 8 equals 4a. And the last step, if we divide both sides by 4, we can see a is negative 2, and I'm done. And when I say I'm done, remember a was the only value that we did not have, and now we have it. So our function written in vertex form is going to be f of x equals a x minus h minus h. Remember h was negative 2. Minus a negative is going to make that a plus 2. Don't forget your squared. Plus k, which was 6. And that is our quadratic function in vertex form. And as an added bonus, we're going to play the what if game and say what if they wanted it in standard form. Well, this would not be too hard to do either. We're just going to need to multiply this out. X plus 2 squared means to multiply by itself, and we're going to have to do the FOIL method. Here we go. First, x squared. On the outside, we have a 2x. On the inside, another 2x. Last but not least, plus 4 plus 6. And then if I use the distributive property and combine like terms all at the same time, we're going to get negative 2x squared. We would have a negative 4x and a negative 4x, making negative 8x. Negative 2 times 4 is negative 8, plus 6, negative 2. And that should be our quadratic function in standard form. Okay, bonus material. I couldn't help but throw in some Desmos here because I love using Desmos to verify results. So what we're going to do is we're going to verify that our function in vertex form is the same as our function in standard form, while we also verify the vertex and the other ordered pair that was given on the graph. So we're going to start by inputting this function, f of x equals negative 2 x plus 2 squared plus 6, and there is the quadratic function in vertex form. We can verify the vertex is negative 2, 6, and the other ordered pair that they said was on the graph was negative 4, negative 2. So we're just going to input that ordered pair and make sure that it falls on the graph, which it does. So can you see that Desmos is verifying that my vertex form is correct because it gives the same vertex and ordered pair that were given on the graph I was given. And now we can verify our standard form is also correct. F of x equals negative 2x squared minus 8x minus 2. And then here, the cool thing, you can turn that off and on. And if those graphs are identical, then these functions are identical, which means these are both correct forms of the quadratic function. And that's going to do it for this particular lesson. So if you have any questions or comments about anything that I covered, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.